In this example, notice that it's a decimal, but don't worry. Same idea as always. We're still going to try to solve for 1n. And right now I can see that this is negative 0.3n if I were to ignore that 6. And in order to solve for n, I'm going to have to cancel out this term here, the 6. So this, if you notice to the left, there's nothing next to it. That means it's a positive. And to cancel out 6 positives, I'm going to put 6 negatives. And what I do on this side, I got to do the same thing on the other side. So I'm going to do 6 negatives here. And what I'm going to do now is simplify. 6 positives and 6 negatives cancel each other out. That's a 0 pair. And now I bring down my term. Negative 0.3n is less than 9 minus 6, which is 3. And now I have to get one whole amount of n. I don't want negative 0.3, and I want 1n. And in order to do that, I'm going to use a division property. I'm going to divide this by negative 0.3 because anytime you divide a number, as long as it's not 0, when you divide it by itself, you're going to get one whole amount always. So we can use that for this problem, and I'm going to balance it by doing the same thing on the other side. Just like when you solve an equation, you got to do the same thing to both sides. So here we're using the division property of inequality. And now when I simplify, I'm going to get one whole amount. Let me just change that to black. So one whole amount n, so 1n. And notice I divided both sides by a negative number. Since we divided both sides by a negative number, that is going to affect the inequality sign. And if you don't know why, make sure in the worksheet you go back to the previous section when you had to solve, using division or multiplication. There's a video that's going to walk you through why we have to flip the sign like we did in this case. You don't want math to be a mystery, so make sure you understand why we flip it. Otherwise, you're going to make mistakes over and over. So take the time to learn why we flip it. That way you prevent future mistakes, and that way you save time and you can continue making progress in math. So when I divide this out, I'm going to get negative 10, and that's my solution set. So any number bigger than negative 10 will be a solution. So if I ignore this work that I did, it'll be a solution to this inequality up here. So any number bigger than negative 10 will make this inequality true. And now I'm just going to graph it. So I'll put negative 10 in the middle. I'll put a number before and after, so negative 11, negative 9. And then numbers greater than negative 10 means don't include it. So I'm put an open dot. That means we're not including it. And bigger than negative 10 on a number line, bigger always goes to the right. So I'll just shade in this. And this will be my solution set. So any number I pick going afterwards, negative 10, so going to the right, including numbers in between negative 9 and 10, but not including this. So like this is saying like negative 9.1, negative 9.5. So any numbers, so all real numbers will be solutions as long as it's bigger than this number here. Any of those numbers will be solutions to this inequality up here. And any of the numbers on this side that are less than negative 10 will not be solutions, meaning when you substitute a number, like if you did negative 11, if you put negative 11 in there, you're going to get a false statement. You're going to get a number that is not less than 9. It's actually going to be bigger than 9. And similarly, if I pick a number like negative 9 and substitute it for n and simplify, I'm going to get a number that's less than 9. It will be true. And that's what we mean by a solution set. There's more than one answer that will make that inequality true.